Hello everyone, my name is Hyunjeong Lee from Yonsei University. I'm going to talk about my research paper, which title is Multimodal Turning Place, a comparative analysis of visual and auditory recent UIs in related walking. I have worked with Dr. Hyunjeong Kim and my advisor, Professor In-Kwon Lee. Experiencing virtual reality by walking through an infinitely large virtual space gives its user a high sense of presence. However, when experiencing it in a small physical space, the user must perform resets to readjust their walking direction, just like in this video. There are many different reset methods, but the most common is the turning place method, which uses a rotation gain to create a difference between the amount of rotation in the physical space and virtual space. So that in the virtual space, they stay in the direction they're walking, and in the physical space, they move away from the wall. Various strategies have been proposed to determine the direction of the reset, and this have contributed to reducing the frequency of resets that occur during the experience. These reset methods have also evolved to be combined with redirected walking, which calls RDW, to explore virtual spaces while utilizing real-world spaces more efficiently. Many reset strategies have been proposed, but how do we tell users to do it? We mostly use visual UIs on the HMD screen to signal the reset, the direction UI to indicate the direction where to turn, and endpoint UI to indicate the endpoint of the rotation, and error alignment UI. However, over the years of research, we found that users don't always do exactly what the optimized reset indicate is, and since resetting is a process that requires users to overtly stop what they're doing, there's a risk of breaking presence and motion sickness if done frequently. So we researched and compared what the most optimal UI would look like and how it should be designed, and whether we could utilize other senses when we currently only visually direct reset. We first interviewed experts who have done research using resets to find and summarize the problems of the current reset process. Then we proposed a novel visual reset UI to solve these problems and conducted a comparative analysis focusing on the problems identified by the experts. However, since visual alone cannot solve all the problems, so we proposed a multimodal reset method that utilizes auditory rather than visual and conducted a comparative experiment. After interviewing 4 experts, we identified the following problems. In accurate rotation, where the user does not perform the direction indicated by the resetter correctly, late recognition, where the user is late in recognizing reset instruction, unrecognized turning direction, where the user does not recognize exactly which direction to turn, and tricky process, where the process itself is difficult. We experimented with the previously proposed direction, endpoint, and arrow alignment reset UIs and our new gauge UI. The direction UI instructs the user to reset with the praise turning place and arrow in front of the user's eyes. The endpoint UI has a cylinder representing the endpoint and an X symbol in front of the eye to the direction UI to indicate the exact endpoint to the user. The arrow alignment UI phrases the user screen and displays arrows in the direction the user is facing and the direction the user should be facing. Our novel proposed gauge UI shows the progress of reset via gauges. We conducted a user study comparing 4 UIs where participants experienced the virtual space once using each UI and completed the questionnaires and interviews. Let's talk about our experiment. Participants walk 80 meters in a virtual space. It's decorated like walkway, and each with a recent UI. Our independent variable is the 4 recent UIs, DI, EP, AA, GA, and the dependent variables are logging data to measure navigation performance. mean distance between reset, which calls MDBR, and mean reset angle error, which calls MRAE, mean reset position error, MRPE, and experimental time, ET. In addition to major user experiments, participants were asked to complete several questionnaires to measure thickness, immersion, presence, usability, and cognitive load. Finally, we asked them to rank their preference for each UI, and in total, 24 participants took in the experiment. We had two hypotheses. The first hypothesis, applying a different recent UI to real experiments will result in a different impact on navigation performance. And hypothesis 2, applying a different recent UI to the real experience will result in different impact on the UX. So, as you can see, it is the result of the logging data, the gauge UI. The purple one had a significantly higher main MDBR than other UIs, and impact of MRAE endpoint. Sorry, yellow. Endpoint also had the lowest MRAE, followed by the gauge and direction. We found significant differences in navigation performance by recent UI. And let's talk about the result of the questionnaire we conducted it to determine the impact of each UI on user experience. There was no significant difference in cognitive load as measured by NASA TLX. However, we found that the gauge UI was significantly higher IPQ presence and as well as usability. At the end of the experiment, participants were asked to rank the 4 UIs in order of preference. The gauge UI was the most preferred with direction, and endpoint ranking is close behind. However, visual alone cannot solve all the problems. In response, we proposed the novel recent UI that uses auditory cue to instruct reset. We compared it to the gauge UI, which performed well in study 1. And the auditory UI utilized 2 channel stereo sound to indicate which direction to turn in place. As you can hear in this situation, your left ears can hear the sound. And we also propose recent UI that utilizes multimodal sensory in combination with the gauge UI. We conducted a study to determine which types of sensory instructed reset is better for user experience and navigation. The experimental method and data collected are identical to study 1, and in study 2, the total of 28 participants performed the experiment. And this is hypothesis of our user studies 2. And as you can see, the type of sensory cue that prompts the user to reset will affect navigation performance. The type of sensory cue that prompts the users to reset will affect the user experience. Okay, first let's talk about the logging data results from the study 2. We found that the auditory UI had a significantly higher MDBR than other UIs, indicating that it was better in terms of navigations. However, the user experience aspects of the questionnaire showed conflicting results. Auditory had a high cognitive load and low immersion, and presence, and usability. In the end of their preference, users say that the multimodal approach blended the best of both senses and minimized the worst. Okay, it is our research conclusion. We identified the problem that the current recent UI does not fully exploit the power of the improved resetter, and therefore we proposed a reset UI that utilizes different designs and sensibilities and found that can improve user experience and navigation performance. There is a room for further improvement by proposing new designs or UIs that utilize new senses such as haptics in the future. Thank you for listening to this presentation. Thank you.